All right, chapter 1 and 2 review. For this one, we're going to do a number 4, E. And here we're checking for origin of symmetry and x-axis of symmetry, or y-axis of symmetry. There's also an x-axis of symmetry that we can test for, which I will also do just as a bonus. So to set it up, we have the origin of symmetry, where we would test negative x and negative y, the y-axis where we test negative x and y, and then the x-axis of symmetry where you test x negative y. Okay, now this is one way to look at symmetry. Usually though, for origin and y-axis symmetry, you can do what I like to call the negative x test, where if you plug in negative x and you get the exact opposite for the y, then you know you have origin of symmetry. If you plug in negative x, you get the same y, then you have y-axis symmetry. It's just a different way to think about it, but it's pretty much the same thing of what I'm about to show you. So to help you understand origin of symmetry, I'm going to draw this quick little graph and show you these 2 points on the graph. Notice that these 2 points on the graph, when you plug in x, you get y, and when you plug in negative x, you get negative y. So when you do the opposite of x, you get the opposite of the y. And so in our graph, what we're seeing is we got a 2, 3, which is right here. And then when we plug in a negative 2, we get a negative 3. Okay, that would be origin of symmetry. So how would you test this guy to see if you have this? This is like the conceptual stuff, but how you actually apply it to that. So what I do is I plug in a negative y and a negative x. And what I'm trying to do is I'm trying to see if I get the same thing as this. If I simplify this, would I get that? And so I simplify it, and this is what I have. The negative x squared is just positive x squared. And then I could take a negative 1 out of each sides. And this is kind of extra, I think, but the visual helps you guys see that you could take a negative 1 out of each of those. Then you just divide both sides by negative 1, and they go away, and you're left with y equals x divided by x squared plus 1, which is exactly what we started with. So because we plugged in both the negative x and the negative y, and we got the same thing, we know that we have origin of symmetry. Now let's say you didn't plug in both the negative x and the negative y, and you only plugged in the negative x. Remember what I called the negative x test? What you would get when you're done is a negative y. So this would actually be a negative. If you plug in a negative x, you'll get the exact same as this, but the opposite. Okay? That's if you don't plug in both. But here I'm plugging in both. All right, so next, let's look at the y-axis of symmetry. For the y-axis of symmetry, I like to think about the regular x squared function, the one that gives you a parabola. Here's some points on it that prove that it has symmetry about the y-axis. So essentially what's happening here is when we plug in x, we get y, and when we plug in negative x, what would we get if we had y-axis of symmetry? You would get the same thing. You would get the same y. So in our example right here, if we plug in positive 2, we get 3. If we plug in negative 2, you still get 3. That is y-axis of symmetry. And so if we were testing it, this is the conceptual stuff. This is like the actual doing stuff. You would plug in the positive y and the negative x, and you're trying to see if you end up with the same thing. If this simplifies to give you the same thing right here, then we're gold. Now we know we have y-axis of symmetry. So I simplify the bottom, and it looks like the negative goes away on this guy because of the squared, but then there's still a negative hanging out. So essentially what we got is y equals negative, the exact opposite of what we started with. Therefore, we do not have the y-axis of symmetry because of that negative. Now here's the bonus, the x-axis of symmetry. Now I like to look at the parabola that is sideways. So this is actually x equals y squared. And for this one, you plug in a positive x and a negative y. So essentially what you would do, you plug in x and you get both a positive and a negative y. And I'm plugging in x here, but really I like to call this a negative y test, meaning that if you plug in a positive y, you get x. When you plug in a negative y, you still get positive x. Okay, so this would be the negative y test. These two would be the negative x tests. So for this graph, when we plug in 2 for the x, we get a positive 3 and a negative 3 for the y. Or you could say when you plug in a 3 for the y, you get 2, and when you plug in a negative 3 for the y, you get 2. Okay, so different ways to think about it. So here we go. I plug in a negative y right here, and you can see that nothing really is going to change. We're actually going to get pretty much the same thing over here. We're not going to get the same thing that we started with, so this one does not have x axis of symmetry. There you have it, guys. There's the symmetry test.